Okay, hello year 12s. We're now going to be moving on to 10.2, which is all about iteration. First of all, what is iteration? You've met iteration in GCSE, and an iterative method can be used to find a value of x for which f of x is equal to 0. And to perform an iterative procedure, it's usually necessary to manipulate the algebraic function first, and what we mean by that is we are going to be doing a process over and over again to get to our root. Now, to solve an equation, and the reason why we have to use these kind of methods is, as I said in the previous videos, is that factorization and other methods of solving a quadratic or a cubic don't work, okay? And we need other methods such as iteration to solve an equation. Now, to solve an equation of the form f of x is equal to 0 by an iterative method, we've got to rearrange it in a certain form. Okay, and that form is x equals g of x. Okay, so if we have an equation that's that looks a bit like this, where we've got an algebraic function equal to 0, we're gonna have to somehow bring x onto one side and everything else to the other side. Okay, and then use the iterative formula, which is actually a recurrence relation that you've met in chapter 3, I believe, of sequences. Okay, so you've met a recurrence relation in chapter 3 of your book 2. And use the iterative formula, which looks a bit like this. Okay, what this means is that if I substitute a value, let's say x0 into the function, I will get, the answer would be x1. Then if I substitute x1 into this function, I'll get x2, and put x2 and I'll get x3, and so on. Okay, now let's look at just an example. So if we were looking at, let's say, this is a very small example. I'm going to show you 3 different scenarios that can happen, okay, and then we can move on to examples. So for example, if we had a function f of x equals x squared minus x minus 1, there could be many different ways I can rearrange this to get x on one side and everything else on the other side. I could make this x subject of the formula. Okay, so if I wanted to do that, I need to first make it equal to 0. So I'm going to have x squared minus x minus 1 equal to 0. Then if I have x, because remember I want to make this x subject of my formula, so I'm going to bring everything else to the other side, and I would get x plus 1, and then I would take square root of both sides and I would get this, and then I would convert it into a recurrence relation and I would get this as my iterative formula. Okay, let's pick a starting point. So let x0 equals 0.5. Now we have to pick a starting point, and that starting point needs to be quite close to the root. Okay, how do you know where that point is going to be? Well, it's always given in the exam. They will say start at this point and show that whatever. But what I want to show you now is what different scenarios can happen. Okay, so this formula and this starting value is going to produce something like this. Okay, now as you can see from here, what 2 graphs shall I draw in order to find a root to this equation? Okay, so think about that while I draw this. The 2 graphs that I need to draw are the line y equals x. Okay, so I'm just gonna draw just a very rough y equals x here. And I'm going to draw root x plus 1 graph, okay? And let's say that's gonna look something like this, okay? Now if I was to start at x naught 0.5, let's say that is here, what's actually going to happen? I am going to substitute x naught into this equation. So that's going to give me an output which is going to be this value, okay? But because I'm calling that, because I've got a line y equals x, I'm going to extend this to my line y equals x, and I'm going to read off what that's going to be. Well, this is your x1, because if this is x1, then this is also x1, because we've made y equals to x. Now we are going to input x1 into our original function, and that is going to give us an output of x2, which is there. And that is the same as if I went across there, okay? So basically what's happening is I've got x0, x1, x2, and then here I have found my root. So it's gone in a staircase kind of direction, okay? It's gone in a staircase. So basically what I want to say is that if you pick a starting point which is quite close to the root, sometimes you will converge to the root pretty quickly, okay, using a staircase diagram. You don't need to draw the diagram in an exam. They will never ask you to draw it, but it's always good to know what your iteration is looking like, okay? So this is called a staircase diagram, and you have converged to a root in this case, okay? Now, like I said, there could be another way of rearranging this equation, okay? And let's see what happens when we rearrange it in a different way. So if I was to, let's write this again, and if I was to make this x the subject of my formula, then what would happen then? I would have x squared minus x minus 1 equals 0. I would then have x squared minus x equals 1. Actually, what I'm going to do is I'm going to take 1 to the other side, and I will then factorize, okay? So I'm going to factorize it out, and I will get x minus 1 equals 1. And then I will have x. So if I had this situation, my graph would look a little bit like this. Actually, let me start my graph again. My graph would look something like this, actually. So for the y-axis, the x-axis, still the line y equals x, so that's here. And 1 over x minus 1 is, I know, a reciprocal graph, and that's going to look a little bit like this. Now if I was to start, So let me write this again. My recurrence relation looks like this. And let x naught equals minus 2. So what would happen? Let's say this is my x naught. First of all, I input it into this side of the function. That's my output value, which is here. That's the same as this value here. That's x1. Then I put in x1 into my graph. That's my output value, which is the same as this value. That's my x2. Then I substitute x2 into the function. That's my output value, which is my input value. Okay, and that's x3. And actually what's happening is that I am getting closer and closer to the root. Okay, so I've got x3, which is there, then I put x3 and I get this as my output value, which is here, and then I go up and around and around, and what I'm actually forming is I'm forming a cobweb which looks something like this. So it's going round, up, round, round, and it's actually better if I show you in the book what's happening here. So the x naught started from x naught. I got an output which was x1, then I put that into the function. I got another output which was x2, I sub that in, I got x3, and I go around and around and around until I find my root, okay, or until I get very close to my root. Now this kind of a diagram is a cobweb diagram. And the reason why I get cobweb is that I've got a positive gradient here and I've got negative gradient for this curve, which is why my values are oscillating. Here, when I had the staircase diagram, I had a line x, y equals x is a positive. This curve also has positive-ish gradient, which is why I'm getting a staircase. But also, it does also matter where your starting point is. If you choose a wrong starting point, or a point which is quite far away from the root or after the root, then you might not have you might not find a root at all, and you might go away from it. Okay, you might go far and far away from it. And I can show you what that can look like. So again, looking at the same equation, this time I'm going to make this x as my subject. So if first of all I make this equal to 0, then I'm going to have x equals x squared plus 1. This is what my recurrence relationship looks like. My graph is gonna look something like this. And if I was to choose a starting value, let's say somewhere here, then what's going to happen? My output has gone way beyond. That's going to be reflecting on the y equals x. And then I would actually move very far away from the root. It's going to carry on going that way. Okay, so it'll never converge to the root that I want it to converge to. um,